All right, these are your 9-6A notes. And basically, this whole section is a lot of thinking. That's why it says analyzing. And we're going to analyze the functions, all of the functions that we have been introduced to in Algebra 1. And so in first semester, we were exposed to linear functions. Okay, and a linear function, the m is the steepness. It's how much it's rising or falling in this case, right, to how much it's running. So that would be your slope. And then your b value is where it crosses the y-axis. So if you guys remember in quadratics, we said the c value was our y-intercept because there's an extra term. There's that squared term. So this is your y-intercept. We did a whole unit on quadratics. And then in chapter 7, the beginning of this semester, back in January, we were exposed to exponential functions. So this is going to be one of the equations we're working with. With the parabola, though, we're going to make it very simple. We're only going to be exploring parabolas that just have the quadratic term. So we won't have a bx, we won't have a c, we won't even have to find any of that stuff. Okay, and then for our exponential functions, they're going to be written like this. Okay, now they can, depending on if it's growth or if it's decay. If it's growth, it's going to be looking upward. If you want to put a decay example, that just meant it fell. And that's when the b value was between 0 and 1. It was like a fraction. But it would be set up the same way. So you have an a times a b to the x. And in this particular case, your a value was your y-intercept. In the quadratic, a represented how wide or how narrow it is. So it's not where it crosses anywhere. We're not going to worry about where it crosses because it's going to cross at 0. It's going to be a very simple quadratic. So we have 3 objectives. The first objective is if I just graph these things, tell me what you got. But sometimes the graph is very limited. Sometimes the points you have are very limited. And these two can just start looking like each other. If you look at this part of the curve, you may have said, oh, I'm dealing with a parabola when it was really a part of the exponential. So they don't always give you all the ordered pairs. You can't give all the ordered pairs, but sometimes they give you an incomplete set. And so it looks like a quadratic, but maybe it's exponential or vice versa. So we're going to look at another way of looking at the data and figuring it out. And then we're going to also write the equations based off of that information. So 3 steps. First one's pretty simple. Let's just go ahead and get started on that. Whoops. Sorry. All right, so for the first one, we're just going to take these ordered pairs and plot them. Remember, this is your x, this is your x-axis, this is your y value, this is your y-axis. So you go over to -2 first, then up 5. Hopefully we're better at that just from the parabolas. 1, 2, 3. I think I went too low. Sorry, -2, 1, 2, 3, 4, 5. Sorry about that. All right, -1, 2. 0, 1, 1, 2, and 2, 5. Looking at the orders, you could kind of see that the y value is repeating like that. We went lower, 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 then we came back up. So I can tell that those points make a quadratic. We don't have to do anything else but name it in this particular section. For the second part here, -2 1/4. So we're just going a little bitty right there. Guesstimate 1/4. -1 and a little bit higher at 1/2. 0, 1, 1, 2, and 2, 4. And so this one is starting to do that curve, and you can kind of see the numbers keep getting, they're doubling. 2 to 4, 1 to 2, 1/2 to 1. A doubling or a tripling or dividing, you know, that sort of thing. Those are characteristics of an exponential. And obviously, if they had a constant and you saw a pattern within the slopes, I didn't show you one of those. That's the easiest one to identify if they all line up. It's linear. Okay, so I think you guys can handle plotting the points and then naming the function from there. The next part we're going to use when we try to write the equation and also do the same thing we did here, name them, but by looking at a pattern. So we're going to use a pattern to figure this stuff out. So the very first thing we're going to do is look for patterns in the y values. And when we do this, we are going to work backwards and subtract. So I'm just going to put in parentheses, subtract backwards. If you go forward, your signs are going to be wrong. When the slope's supposed to be 3, you're going to get a -3. If the exponential's base is 1/2, you might get 2. So it's going to give you wrong criteria. So it's really important that you work backwards through the tables to help you out, okay? So the patterns we're going to look for are differences, and differences is just the fancy word for subtraction. So we're going to do first differences. And when we talk about first differences, that kind of implies that we might do it more than once, okay? And that's exactly true. Sometimes we just have to compare the first differences. But if not, then we'll do second differences. So first differences, we just subtract, and if they're equal, subtract y values. And then if equal, it's linear, because what we just subtracted there was your slope. And so our first differences is our m value. So if you want to write that there, because that's going to come into handy later on when we're not just naming them, but we actually have to find this stuff. Okay, but let's say when we did that, we got a giant mess. We still want to record it all. So when you do the first differences, you want to record it and write down, because then we're going to conduct second differences. Second differences, you subtract not the y values, but you subtract the first differences. So what you got when you subtracted the first time, you're going to subtract those. And if they're equal, then it's quadratic. And I kind of like to think of this as a linear equation as x to the first, and a quadratic is x squared. And so that kind of helps us out. Now, second differences does not give us the a value. It doesn't give us anything. We have to work for everything. But I do like to put that it's the m value for the first differences. Okay, what happens though? We did first differences and it's not equal. We did the second differences and we realize it's not equal. Through process of elimination now, we know it's not linear, it's not quadratic, so it must be, just through process of elimination, it's going to be exponential. And so then we stop subtracting and we do a common ratio. And we did this back in chapter 7. We did it backwards, worked backwards through the data. And a common ratio is we actually divide the y values. Now, if you do that, you'll actually have the common ratio, which gives you the b value later on. So we're going to put that there. It doesn't really make sense right now, but we'll talk about it in a little bit. All right, so let's look for patterns in each. So again, up above, we graph these things, but it's time consuming and sometimes the data that they give you is incomplete. So it doesn't necessarily give you all the information. So the first thing we're going to do here is we're going to do the first differences working backwards through the tables. So I like to just make these little V's. You can use your calculator. Be very careful when you subtract a negative, right? So we're going to say, we're going to start with 2 and we're subtracting -3. So 2 minus -3 actually ends up being +5. Now I'm going to do -3 to -8. Now, whether they're equal or not, I need to finish this out. You have to do first differences. -3 minus a -8 ends up being +8, also 5. And then -8 minus a -13 is also 5. And -13 minus a -18 is also 5. As soon as you see the pattern with 2, that's not enough. You have to carry it all the way to the end. Okay, and so the fact that they are all equal, these are our first differences. Our first differences are equal. Then we know it's linear. Okay, over here, part B, and actually as I start doing these things, I like to keep track a little bit. So over here on the side, I might put an L, a Q, or an E. We're wondering, is it linear, is it quadratic, or is it exponential? So let's go ahead and do it again. We're going to do the first differences, starting backwards. And the nice thing is, let's just put this on here. I didn't have to write this down, but my slope of this line is 5. That's going to be helpful in the next section. Okay, so when we did the first differences backwards, now had you gone forward, you would have had all negative 5s, and that's wrong. So your whole answer would be wrong. You have to work backwards through the data. Okay, so here we got -7 minus a -9 is 2. -9 minus a -9 is +9 is 0. All right, so at this point, what I'm going to do is I see that they're not the same. So it can't be linear. I still go on, but I just know it's not a line because I have to get them all the same. But I need these first differences to do the second differences. -9 minus a -7 really means +7, so I get -2. And -7 take away a -3 is -4. So they look like a mess. So now what we're going to do is we're going to do second differences. Second differences uses these 4 numbers. So we're going to start at 2, working our way backwards, and 2 take away 0 is 2. 0 take away -2 is also 2, and -2 subtract -4 is also 2. So there's one less, right? That was kind of nice. I had to do 4 before, now I did 3. But the fact that all 3 of these are the same tells me it's a quadratic. It doesn't give me any information, doesn't give me the A value, but it just tells me it's a quadratic that we're dealing with. Okay, if we go on to the top of the next page, okay, again, I like to have that whole L, Q, E over here just to kind of help make sense of the information. And so I'm going to start with my first differences. Okay, and when I do my first differences here, I get, when I subtract a half and then -1, I get -1/2. And then 1 minus 2 is -1. So right now I can cross off, it is not linear, but I got to keep going. 2 take away 4 is -2, and 4 take away 8 is -4. So now I'm going to look at the second differences. I'm going to subtract those other ones. And so a -1/2 minus a -1 is 1.5, positive 1.5. And then -1 take away a -2 is positive 1. As soon as I see that happen, these aren't equal, I can stop because I know now that it's not quadratic and I don't need that data. I don't do anything with that data. I'm going to switch my gears and I'm going to say it's exponential. And in fact, I don't have to do any more work for exponential here. Down below we will. But if I'm just trying to name them by process of elimination, I know it's not linear. I now know it's not quadratic, and so it's exponential. Okay? For time's sake, we're going to skip part D. And we're going to talk about, now that you know what it is, we're going to come up with the equations. So when we come up with the equations, the first thing we're going to do is work backwards. We're going to determine what we're dealing with. Are we dealing with an L, a Q, or an E? So we're going to use the process that we just established. And then after that, depending on which one it is, you're going to use the data from the tables. So you're going to have to plug in an X and a Y to find some different things. Okay, so let me tell you the different things that we have to do. For a linear equation, your answer is going to be like this: y equals mx plus b. Well, you'll have m. Your m value is your first difference. And then you're going to plug in x and y from the table and solve for b. Okay? Pick any order pair in the table, plug in x for x, y for y, plug in m, and then you'll just solve for the little b, and then you'll have your answer. For quadratics, for the quadratic, you're going to write the equation y equals ax squared. Okay? We won't have the a value. We have to find it. but it's pretty simple. You just plug in an ordered pair from the table and solve for A. So you have to find little a. And for exponential, your equations are going to look like this. They're going to be y equals a times b to the x. Your b value is equal to your common ratio. So we'll have to finish out the problem and figure out what the common ratio is by dividing. And then plug in x and y. And solve for A. You'll plug in B too, but you'll plug in an ordered pair, X here, Y here, you'll plug in the B, and then you'll solve for A. In each of these scenarios, I'm going to suggest after you have your equation, I would check your equation by plugging in a different point. And seeing if it's true. Not the same ordered pair that you just used, but a different XY. And I think there's one extra little thing here. For the quadratic, you cannot use 0, 0. So 0, 0 would give everything turn into 0. It's the vertex, and it won't tell you the A value. Everything will just turn into 0. So that's the only ordered pair you cannot use if it's in the table. All right, so let's go ahead and try this a little bit. So for part A, we're going to go ahead and I'm wondering if it's linear, quadratic, or exponential. So using my calculator here, I've got -5 minus a -1 is -4. And -1 minus 3 is also -4. It's looking like linear. 3 take away 7 is -4, and 7 take away 11 is -4. So we got a winner, right? It's linear. Okay, and not only is it linear, but this is your slope. Okay, so your slope is -4, your m value is -4. You use the linear equation like a formula. So y equals mx plus g is what I'm looking for. I'm looking for the name. It's the equation. I have the m value. I need to find the little b value. So I'm going to pick any one of these ordered pairs. I'm going to use this ordered pair right here. So that ordered pair, I know it's stacked on top of each other. It's really the ordered pair 1, -1. So I'm going to plug 1 in for x and -1 in for y. -1 equals -4 times 1 plus b. And -1 equals -4 plus b. Add the 4 over. Add 4. Add 4, b equals 3. So that's not my answer. My answer is y equals -4x plus 3. And if I test it, just to do a little quick mental math, if I test it with -1 and 7, if I plug -1 in for x, -4 times -1 is +4. +4 plus 3 is 7. It works. So it checks out. Okay, let's go on to letter B and move my little tools over here. So for B, I'm going to do 80 take away 40 is 40. 40 take away 20 is 20. 20 take away 10 is 10. 10 take away 5 is 5. So it is not linear. So now I'm looking to see if it's quadratic. So now I'm going to switch to second differences. So I'm going to subtract these. 40 take away 20 is 20. 20 take away 10 is 10. And I can stop right there. It is not quadratic. You might have known that just by looking at the data. Okay, as we get better at these, you can kind of skip some of these steps. If you can tell that it's going to be exponential, then just show me. So what you have to show me is all the common ratios are the same. So let's go ahead and figure out our common ratio. And so it's going to be 80 over 40, right? So if I put these over each other now, 80 divided by 40, and let's just check that it's true. 40 divided by 20.
Students, don't forget that today we are doing Tattoo Your Teacher in the cafeteria. Once again, students, they're doing Tattoo Your Teacher in the cafeteria. Moraine City High School and Moraine City Middle will be doing this at their lunch. Thank you.
Don't forget to tattoo your teacher. All right, y equals A times B to the X is what we're looking for here. I didn't do the green common ratios all the way through because I knew it was exponential because I did the differences. If you look at that and you're like, I bet it's exponential, then you would just have to show me that it's true for all of them and you're done. You can skip all of this work. So you can do some thinking that way. I just kind of, as a rule of thumb, start with subtraction. But if you can kind of guess, go ahead and just, you have to prove it to me though. You have to show me that all of them match. All of them are equal to 2. But by working backwards and putting the 80 over the 40 and the 40 over 20, we get 2. Had you worked this way through the table, you would have got 1/2, and then everything's wrong. So I have my B value. I need to find A. So I'm going to pick any one of these ordered pairs. I'm just going to use 110. You know, I got a mess here, but 110 is my ordered pair. I'm going to plug 1 in for X and 10 in for Y. So it's going to look like this. 10 equals A times 2 to the first. Well, 2 to the first is just 2. And so after I do that math, but I really don't have any math to do, I'm going to divide by that number to get A by itself, and A is equal to 5. So now that I have my A value and I have my B value, my answer is Y equals 5 times 2 to the X. That's not 10X. The 2 is the only thing being raised to the X power. There's your exponential equation. I can check it. I'm going to take 220 here. So I'll check it with the ordered pair, 220. So if I plug in X is 2, 2 squared is 4. 4 times 5 does give me 20. All right, last one, and then you guys are going to do D as your practice problem. So on this last one, we've got 0 take away 2 is -2. 2 take away 8 is -6. 8 take away 18 is -10. And 18 take away 32, I need my calculator for that just so I don't mess it up, -14. All right, so out of my line, quadratic or exponential, not a line. So now I'm going to do my second differences. -2 minus -6 ends up giving me 4. -6 take away a -10 also gives me 4. And -10 take away -14 is also 4. So the fact that these are all the same tells me it's quadratic, but it doesn't give me anything. Like I know we got an M value here and we got the B value here. This doesn't tell me anything, but it's also the simplest form of the equations. So when we do this equation really quick, Y equals AX squared. The only one I cannot use is 0, 0. So I just plug in values and solve for A. I'm going to pick values that are pretty easy to work with. How about -2, 8? I like to write them sideways just so I know, maybe label them. I'm going to plug in 8 for Y, finding A. Make sure you put parentheses around it so that you square the -2. When I square -2, I get +4. It's kind of a weird way to write it, but it doesn't matter because we're going to divide by it anyway. It's really 4A. Divide by 4, A equals 2. Not done. That's the A value. Put it all together. Y is equal to 2x squared. Let's check it. I'm going to use this one right here, -3, 18. Just doing some mental math really quick. If I plug in x is -3 and I square it, I get +9. +9 times 2 is 18. Easy way to write your equations. So no lesson summary, but go ahead and do part D for your practice problem. Good luck.